I welcome you all to this wonderful session. So we started waves and we are starting sound in today's lesson. And I want you to know that sound is a what? Is a longitudinal wave. This is what I want you to know. This is a what? This is a longitudinal wave. By definition, we know and understand that longitudinal waves, these are the type of waves whose particles vibrate parallel to the direction of the travel of a wave. So whenever we are talking about sound, sound is an example of a longitudinal wave. So I want you to know this. I want you to understand what I'm telling you. Just make sure you are able to write down these things that I'm telling you. So when we talk to someone, the sound is transmitted in the air. In this case, some molecules in the air are pushed and some molecules of air are further apart. This motion of molecules transmits the sound. This is what you need to understand. So you are going to understand that molecules just vibrate to and from. So molecules do not move across the medium. They don't move. So I'm telling you that whenever we are talking about sound, you need to understand that molecules just vibrate. They just do what? They just vibrate to and fro. This is what you need to understand. They don't do what? They don't move. The molecules, they do not move. They do not move across a medium. They do not move across a what? Across a medium. I will just say across the what? Across the medium. This is what you need to understand. So they just vibrate. And you need to understand that this, where we've got a slightly high pressure, so a slightly high pressure where we've got these particles where they are put together, we've got high pressure. So I'll call this part as A. I'll just call this part as A. And here this part, I'll call this part as what? As B. So at A there, at A, that part where we've got a slightly, so I will say when we've got a slightly, so a slightly high pressure press, high what? High pressure press, a slightly high pressure press is called what? What do we call it? We call it what? This part is called compression. It's called compression. So where is compression? This part A, where the pressure is very high. So a slightly high pressure press on a longitudinal wave is called what? Compression. This is what you need to understand. And we've got a B. What do we call a B? A B that is a slightly, have you seen? That is a slightly lower. So that is a slightly lower pressure press. Slightly lower pressure press. Slightly lower pressure press. Here it's higher pressure press. So higher pressure press, lower pressure press is called, that part, the B there, this B, is called what? Rarefaction. We get to call it rarefaction. So I want you to understand this. We get to call it what? Rarefaction. So this part B here, where we've got slightly lower pressure, that part or this press is called rarefaction. Where these are compressed, from the way they are compressed on one press, we get to call it what? Compression. This is what you need to know. This is something that you have to understand. You also need to understand, I've already told you that sound wave is a longitudinal wave because the direction of molecules, vibration, and the direction of the traveling waves are in the same. So discover that the wave, the particle is going this direction. Even the direction of the wave, it is in that direction. From the definition, we know that longitudinal wave is a type of a wave whose particles vibrate parallel to the direction of the travel of a wave. So when we say these lines are parallel lines, what we mean is that when lines are like this, it means that these two lines are what? Are parallel to each other. So this is a type of a wave whose particles, this is a particle, vibrate parallel to the direction. This is the travel of a what? Travel of a wave. Travel of a wave. So whose particles vibrate parallel? They are all in the same what? Same direction. This is what we mean. So this is some important stuff that you have to get even as you get to answer certain exam questions. You also need to understand that sound needs a medium for it to travel. Sound, we say sound needs a what? Needs a medium for it to travel. This medium can be a what? A solid. It can be a liquid or what? Gases. This is what you need to understand. That is a medium. So you discover that sound cannot travel in a vacuum. Sound cannot and will never travel in a vacuum. Sound do not travel in a vacuum. This is what you have to understand. Sound cannot travel in a vacuum. And you discover that sound travel faster in denser media. So this is what you need to get. Sound travel. So I will say sound travel faster. They travel faster in denser media. In denser what? Denser media. This is what you have to understand. This is to tell you that it travel faster in liquids than in gases. And it travel fastest in solids. So what I mean is that sound travel very fast in what? In solids. Followed by what? Liquids. Then lastly, it's what? Gases. So I'm telling you to say sound travel faster in what? In liquids than in what? In gases. And fastest in what? Solids. So sound will travel fastest in solids, but faster in what? Liquids, then slower in gases. So if I tell you, when you are given these three mediums, where is sound going to travel very fast? It is in this one, followed by this, then lastly that one. So this is the mechanism that you have to understand whenever we are talking about these same things. You now discover that if we are talking about the speed of sound, so the speed of sound in air, maybe if you get to find some multiple choice questions. So if we are talking about the speed, so if we are talking about the speed of what? Speed of sound. So the speed of sound in air, this one is commonly used. The speed of sound in air is about 340. So it's 340 meter per second. But when we are talking about water, in water it is about 1,500 meter per second. When we go to a solid, let's say iron. So when we go to a solid, we say iron. When we go to iron, so in iron it is about, so in iron it is about let me do this, it's about 5950 this meter per second squared. This is what you are supposed to know. These are certain things, certain information that you have to know. So let's make sure that we are able to know these things. We make sure we are able to analyze the question that we are given in an exam. So since we know, and you know that here, maybe if they tell you the degrees, In air, it's about 15 degrees, water 25 degrees. So here it takes place at what? 15 degrees Celsius. Here it takes place at what? 25 degrees Celsius. So if the temperature, you are told to find the temperature, you are able to calculate all those things. So this is something that you are supposed to know. These are some basics that you have to understand. Let us now move to what we get to call the speed of sound. We look at the speed of sound. So I guess we are moving together. You are able to follow me clearly. If you are to encounter such questions in an exam like this, you'll be able to answer them. So let's go to the speed of sound. Okay, so we start speed of sound. I'm just from telling you to say that in the air, when we are talking about sound in the air, I'm just from telling you that in the air, sound travel at the speed of, at the what? At the speed of, at the speed of what? At the speed of about 340 meter per second. At what? At 15 degrees Celsius. This is what I'm just from telling you. And I want you to know that there is what we call pitch of sound. There's what we call a pitch of sound. And I want you to know that whenever we are talking about a pitch of sound, what we mean is that for sound to be louder, you discover that there are people that when they are speaking or talking, the sound is too low. So this is sound. So I say sound like this. That's the correct spelling. So now you discover that the pitch of sound shows the high or low the sound is. This is what we mean. So when we say this is the pitch of sound, it is just showing us. So it is doing what? Showing how. So showing how low or high. How low or high the sound is. The sound is. This is what you mean. This is what we mean. So when we say this is the pitch of sound, so it's just how high or how low the sound is. For example, girls, you discover that their voices are high pitched compared to boys which are low pitched. This is what you need to know. So discover that girls, the voice for girls is high pitched. When they are talking, biology will tell you that the reason why it is like that is for attraction. That's what biology will tell you. So that is for girls. For boys, you discover that that is low pitched. So this is what you are supposed to know and understand. You also need to know that the pitch of sound depends on the frequency. So we are saying that the what? The pitch of what? Sound depends on the what? Depends on the frequency. So it depends on the frequency. This one gets to depend on the what? It depends on the frequency. You discover that low pitch is low frequency and high pitch is high frequency. This is what we get to mean. So low pitch, that is low frequency. High pitch, that is high what? High frequency. I guess we are moving together. You're able to follow me clearly. So this is what you need to know. This is what you need to understand. So you discover that a man can listen to sound waves with the frequency ranging from a person. So this is a person. So I will say a person. I will say a person can listen. A person can listen. A person can listen to sound waves. Person can listen to sound waves of frequency of what? Of frequency of frequencies. So I'll say of frequencies ranging. This is a range. Ranging from where? Ranging from 20 Hz. 20 Hz to what? 20,000 to 20,000 Hz. This is what you need to know. So this is the audible frequency range. So if I tell you what is the audible frequency range, a person can listen to sound waves of frequencies ranging from 20 to 20,000. So you only get to listen to frequency on this range. This is a range that you have to get. So this is something that you need to know, something that you have to understand. So this is something that is so easy to know, something that is so easy to understand, just like this. So even as you are writing down these notes in your book, okay, so it is from here now where we now get to look at the loudness of sound. So we now go to what we get to call loudness. So I'll say loudness of sound. So I'll say this is loudness of sound. Loudness of sound. So on this one, you need to understand that the loudness of sound, whenever we are talking about how loud something is, so the loudness of sound depends. So the loudness of sound depends on the frequency. This one gets to depend on the amplitude, sorry. So it depends on the amplitude. It is going to depend on the amplitude of the wave. So it depends on the amplitude of the what? Of the wave. So loudness of sound, it depends on the amplitude, but the pitchness of sound depends on the frequency. Loudness depends on the what? Amplitude. This is what you have to understand. So you need to know that a sound wave with larger amplitude contains more energy and therefore it is louder. So this is a wonderful point that you have to take note of. So you have to take note of that. So what I'm saying is that a sound wave, this is a point that I'm writing down here. A sound wave, so I mean that a sound wave with larger, so a sound wave with larger amplitude. I gave you the definition of these words: frequency, amplitude. I guess you know them. So a sound wave with larger amplitude contains, this one gets to contain, so it contains more energy. It contains more energy, So I'll say it contains more energy, it gets to contain more energy, and therefore it is what? Louder. Therefore it is louder. So this is some things that you are supposed to know. This is what you have to get and understand. So let's make sure that we are able to follow up this. Let's make sure that we are able to know these things. So this is what you are supposed to know. Then quickly, we now go to the last thing that we are going to do. The experiment to determine the speed of sound in air. This is what we are going to end with. This is the last thing that we are going to do in this particular lesson. So this is where we are going to end from. I guess you've followed me correctly and very well. Let us now go to, this is an experiment. So this is an experiment that you have to understand. This is an experiment. So what is this experiment? Got to determine. So this experiment, what are we doing? To determine. To do what? To determine the speed. We want to determine the speed of what? Sound. To determine the speed of sound in air. This is something we want to determine. So how then do we determine the speed of sound? For us to determine the speed of sound, there are two methods that you need to get. The first method that you have to understand is called the direct method. So there is a method that is called the direct method. So when you want to determine the speed of sound, you have to know the first method that is called the direct method. And this method, you need to make sure that you understand it. So I want you to understand what I'm going to tell you. You are going to answer a question here. So here, with the head of a diagram, so head of a diagram, so head of a diagram, I want to explain this with the head of a diagram. I get two people. This is you here. This person here. This person is having a pistol. So the person is having a pistol. So I'm going to call this person as observer A. This person is observer A. I'll also call this person that is here. I've got this person here. So this is a person here. The person is having a watch like this. So this person is having a watch. This is a stopwatch. So I'll say this is a what? A stopwatch. This is a stopwatch. Then this one, it is called a pistol. We call it a what? A pistol. It is a pistol. I guess you know what a pistol is. So this is what we need to know. This person, I'm calling this person as observer B. So this is what we are supposed to know. You need to write down this in your books. So to start explaining this, what you need to get or what you need to understand is that you need to have two people. So observer A and B should stand at a known distance. This is point number one. You are explaining. You say point number one, you say two observers. So two observers. Two what? Two observers. Two observers, A and B, to stand at a known distance. To stand at a known distance. So the two should stand at a known what? Known distance. So the two should stand at a known distance. This is point number one that you have to note. So two observers to stand at a known distance. The other thing is that when they stand at a known distance, you measure the length. So you measure the length. Then point number two that you have to note, observer A. So I'm going to say observer A. I'm going to say observer A starts. Have you seen observer A starts? Or I'll say observer A fires. Fires the pistol. Fires the what? Fires the pistol. When you say when observer B, so say when observer B sees, when observer B sees the fire, sees the what? Sees the flash. I will say when he sees the flash, pa! So when a gun is fired, the first thing that is seen is a flash. Pia! Before you even hear the sound, boom. So you get to hear the what? When you see the flash, pia! Of the pistol. Flash of the what? Of the pistol. When you see the flash of the pistol, starts the stopwatch. Starts the what? Starts the watch. So it starts the watch, which is a stopwatch. This is what you have to understand. So when he hears the sound, he stops the stopwatch. Point number three is that when he stops, so I'm going to say he stops the watch. This is a stopwatch. We need to be clear. So you finish. You say he stops the stopwatch when he hears the sound. So he stops the stopwatch upon hearing the sound. Upon hearing the sound, upon hearing the sound, this is what is happening. Upon hearing the sound, and measures the what? And measures the time taken between the starting point and the ending time, and measures the time. You now discover that the time interval between them can be calculated by using the formula, in a case where we say the speed of sound can be calculated using the formula. So this can be calculated using the formula. Velocity is equal to s, which is distance, over what? Over time. So that one, that is distance. Down here, this is what? This is time. So they can be calculated using this formula. So at the end, you even conclude that the speed of sound using direct method can be calculated using the formula velocity is equal to distance over time. This is what you are supposed to do. This is the first thing you need to get. This is the direct method that you've started with. The exercise is very simple. I want you to write this in a paragraph form. So the same points that you've written down there. So in an exercise, so let me say exercise. So this is where we get to end from. So let me do this. Let me give you a simple work now. A simple work which you have to submit. So I want you to submit this. I want you to submit this. So an exercise. I was giving you in point forms, but I want you now to write as a paragraph. So this is an exercise, a simple exercise. So I will say, briefly explain how you can determine the speed of sound in air using the direct method. In an exam, they won't specify, but if they specify, meaning you know what to do. They can give you echo or direct method, but if they just tell you that determine the speed of sound, then you can answer it using echo way or direct way. But in this lesson, we've just done one part, which is what? Which is direct method. So I want you to explain in an essay form. You explain like an essay. You say, okay, this, just like that. So that's what I want you to do. You start, okay, nicely. I guess you know when we say write a wonderful letter, you know, okay, for us to determine the speed of sound, the first thing, you make it nice. The person that is reading your essay should feel nice. Okay, this person knows what he or she is talking about. You make it sweet like that. You make it nice. So I want to see nice paragraphs. I want to see nice essays. The point that I will even feel nice even as I'm reading, how you get to determine. You spice it up. I guess you know. Make it sweet. So this is where we end from. Waiting for this exercise.